Hey crafters, this is Nilton from craftofprogramming.com. Today I'm going to be discussing one very hot debated topic, which is the object notify versus object notify all in Java. Now, if you Google these, you will see that there are a lot of answers, a lot of explanations, and there is still a lot of confusion about what exactly is the difference between object notify and object notify all. On Stack Overflow, the awesome Stack Overflow website, you will see that there is here a thread that has been, the question is the difference between notify and notify all. It has been viewed 229 times. And there's a lot of answers. It's been bookmarked quite a lot of times. Also, myself, when I interview candidates for Java positions, when it comes to Java multithreading, this is always one question that comes up. Okay, let's try to dissect in this video what is the difference between notify and notify all, and when should you use which. Okay, let's get started. Alright, so you need to have some basic understanding of object monitors, object locks, and in particular when to use wait, notify, and notify all. So if you are completely new to that, then please, click on the description below. I have a link to a playlist where I have a lot of videos about Java multithreading, in particular what Java threads are, how to create Java threads, and how to use monitor, wait, notify, notify all. I'm also going to put a link here to the card on my video about notify, notify all, and wait. Okay, so make sure you watch those videos and then come back here for this discussion. Instead of coming up with my own example, let's dissect this Stack Overflow answer. And so the question is, what is the difference between notify and notify all, and when should you use which? So the key difference between notify and notify all is that notify notifies one single thread waiting on that monitor's wait set. So only one thread will be woken up, whereas if you call notify all and there are multiple threads waiting on that monitor's wait set, then all of those threads are going to be woken up. That's the key difference. Now, when should you use which is another question that comes up. Notify all typically is a solution to a problem of producer and consumer, right? That's typically the scenario where you would use that. So let's look here in Stack Overflow for a simple problem here, which you see here. So consider a problem where you have a buffer, right, with size 1. Okay, and then consider that you have a producer thread that needs to write to this buffer and a consumer thread that reads from this buffer, right? So you see that there needs to be some sort of coordination, right, between these two threads. Why? Say that the producer is trying to write to this buffer, but the buffer is full, i.e. the consumer has not consumed the value from the buffer. Well, in this case, the producer needs to wait, right, until the data is read or consumed by the consumer before proceeding. So that's basically what you see here, right? So this is highly simplified, but that's basically the gist of producer and consumer problem. While the buffer is not empty, i.e. is full, then the producer waits, and then it is notified or woken up by the consumer as soon as the consumer reads it, and then the producer puts the data in, and then it notifies the consumer that may be also waiting. From the consumer side of things, then it's actually the opposite. While the buffer is empty, then the consumer needs to wait, and then it's going to be signaled or notified by the producer as soon as there is data, and then the consumer is going to wake up, is going to read the data, and then is going to notify the producer that may be waiting. Okay, so that's the gist of the producer consumer. What is the problem of notify and notify all? Well, that's what we're going to be looking here, but the short answer is, if for these sort of problems where you have a producer consumer scenario, right, if you have more than one producer or more than one consumer, you should always use notify all. So your default notification should really be notify all. If you have only one producer and one consumer, then using notify should suffice, but by default, you should use notify all. Now, why is that? It is because when you have more than one producer thread or more than one consumer thread, then if you use only notify, your code is deadlock prone. It is likely and possible that you are going to get into a deadlock scenario, and that's exactly what I want to talk in this video. This is the problem we're going to look at. Again, to give credit to the Stack Overflow users here, Marco, which is he created a nice diagram explaining a specific scenario of interleaving and thread scheduling that led to a deadlock. He built upon an excellent answer, again to give credit to the users here, by the user XAGYG. So kudos to XAGYG as well as Marco, coming up with these great answers on why for this type of producer-consumer problems using Notify may lead to a deadlock. Now the user XYGYG came up with a deadlock scenario that involves 6 threads, 3 producers, 3 consumers. It's a bit more complicated to understand why using Notify may lead to a deadlock. I prefer the answer from Marco here because it has a nice diagram, but also because it has less threads, so it's simpler to understand. His scenario basically has only 4 threads, 2 producers, 2 consumers. Let's take a look at why using Notify may lead to a deadlock. Okay, so, remember the problem is very simple. Okay, so you have the producer is executing this code inside synchronized let's say monitor, and while the buffer is not empty, it just calls wait, and then it wakes up, calls put, and then it calls notify. Consumer, again executing this code inside the synchronized method. While the buffer is empty, it waits, and then it is woken up, and then it takes and notifies. Okay, so in order for you to understand this discussion of why using Notify for this type of problems may lead to a deadlock, right? You need to understand something very important about Java thread monitors. Let's take a look at my diagram here. This is a diagram from a video that you will see in my Java thread playlist. I'm also going to put a link here for a card here for this video. And one thing that you really need to understand, and that's a big gotcha for juniors and maybe even senior developers I've seen having this problem, which is when a thread, right, that is waiting gets woken up, and this wait is inside a synchronized block, right? The thread it's put onto the runnable state, right? And then when it gets scheduled, because it is inside a synchronized block, it will still try to acquire the lock, right? So it's not automatic that a thread gets woken up and then it immediately starts running. No, the thread still needs to, like I said, when it gets scheduled, it still needs to seek the lock, right? And it may not acquire the lock. It may become blocked, okay? So this is very important to understand this thing. So one different way of thinking about it is that you may think of Java monitors having 2 wait sets, right? There is one wait set for threads that call wait, but there is another wait set for threads that call a synchronized method, right? For the threads waiting on the wait set, they are always woken up by a notifyAll. Let's ignore the timed wait for this discussion, right? The threads waiting on the blocked quote-unquote wait set, right, are basically unblocked when a thread releases the lock, right? Okay, so this is very important that you need to understand for the discussion. Okay, so let's now talk about this in detail. Okay, so now that you understand this very important behavior, let's talk about why calling notify for this very simple problem with only 2 producers and 2 consumers may lead to a deadlock. Let's look at this. Imagine that the first thread to be scheduled is, by the way, P is for the producer and C for the consumer. You have P1, P2 and C1, C2 because we have 2 producers and 2 consumers, like I said. So imagine that the first thread that gets scheduled is the producer. So the producer is going to write to the buffer put, and then it's going to send a notify. The notify is lost, right? So notify is not sticky, it's not persistent. It doesn't, if there is no threads waiting on the wait set, then it's just lost. If a thread then tries to call wait after, right, it's just gonna wait, all right? So anyway, P1 writes to the buffer, calls notify, it's lost because no threads are waiting. And then imagine that the thread then releases the lock, because it's running on synchronized, and then it goes back, call that blocked method, so write. So it's gonna wait on full because the consumer has not read. Then imagine the producer 2 gets scheduled, right? And one important thing you need to remember is that when a thread calls wait, it releases, right, the monitor's lock, right? Remember, the call of wait is inside a synchronize block, or in this case method. So when it calls wait, it releases that lock. So because the lock has been released, P2 has been scheduled, and it acquires the lock and then checks the condition. The buffer is still full because no consumer has read, and it's going to wait as well. Again, when P2 waits, it releases the monitor's lock. Okay, so at this point, when the first consumer thread comes to read, you have both P1 and P2 waiting on the monitor's wait set. Okay, so the consumer 1 acquires the lock, and then it consumes the buffer data, right? And then it notifies, right? Now remember, notify only notifies one single thread. Okay, which thread is going to be notified is completely dependent on the Java thread schedule. You do not have any control over it, right? So and there is no order on the which thread is going to be woken up. Why? Because it's a wait set. It's not like a queue or with first in first come order, right? So notice that in this example here, P1 waited before P2, right? But because there is no order, there is no guarantee that P1 is going to take any priority on acquiring or being woken up before P2, right? So again, C1 consumes the data and then notifies, guess what, P2, all right? So when it notifies P2, now remember, P2 will still need to acquire the lock, right? The synchronized lock. But before it acquired the synchronized lock, C2 got scheduled, right? And acquired the lock first, okay? Because the buffer was empty because C1 had just consumed it, C2 is waiting. Now again, C2 waits, it releases the lock, and then for P1 is able to acquire the lock, P2 gets scheduled again, and it beats P1, and P2 acquires the lock, puts the data in, and notifies P1. All right. Remember, the lock is going to be released here, and P1 is going to acquire the lock, is going to see that the buffer is full, and it's just going to wait. Now, P2 gets scheduled again. Remember, when P1 waits, it releases the lock. P2 acquires the lock, sees that the buffer is full, and is going to wait. So at this point, when C1 is going to be scheduled and enters the synchronized lock, P1 and P2 are both waiting. So again, C1 is going to consume the data and is going to notify C2, which has been waiting here, right? And that's where the deadlock occurs, right? So C2 is going to be woken up, is going to acquire the lock, and basically the buffer is empty, so C2 is going to wait, okay? And then, let's say C1 then gets scheduled again, and it's going to enter the synchronized block, acquire the lock, and it's going to wait. So now you have this deadlock problem where both C1, C2, P1, and P2 are waiting on each other, and that's the canonical lock, right? So that's the scenario that these users came up. Now let's see why using notifyAll, which is something that they did not explain, solves the problem. So basically, I have here the scenarios here. I have two scenarios, and I'll explain to you why. So I have the code here for the producer and the consumer so that you can look it up. But let's look at this in detail. So just like before, by the way, I'm going to go with the same sort of sequence of scheduling that they were using. And what I've done here is I've replaced the call of notify to notifyAll. But I'm going through, I'm basically using the same steps. Okay, so we have our 4 threads, our 2 producers and 2 consumers, just like in their example on Stack Overflow. the producer is the first one to be scheduled. It writes to the buffer, and then it calls notify all. Just like before, because there are no threads waiting, this notify all call is lost. And then P1 here gets scheduled again, acquires the lock, and waits on full because no consumers have read, the buffer is still full, P1 is going to wait. Remember, after it waits, it releases the lock, and then just like before, P2 gets scheduled, it acquires the lock, it checks the condition, the buffer is still full, so it's going to wait. After it waits, it releases the lock, and then C1 gets scheduled, acquires the lock, checks the condition, buffer is full, it consumes it, and then it calls notify all, right? That's the difference here. This time, this notify all is not lost. It's actually been, it's going to wake up all the threads waiting on this wait set, which is P1 and P2, okay? So then, just like before, right? While P1 and P2 are seeking the lock, right? C2 beats them to it, right? Gets scheduled and acquires the lock before them, right? And then because P1 and P2 have not executed yet, the buffer is empty, so C2 is going to wait. This is the same sort of sequence that they had before. I've just changed from notify to notify all. Just like before, P2 acquires the lock before P1, okay, and calls notify all, right? This call here, notify all, right, that's going to wake up C2 that is waiting, right, is where there is a key difference. All right, so what is the difference here? The difference is that notice that when P2 calls notify all, right, you have P1 that it's still waiting on the it's waiting for the lock to be released, right? Okay, because it got woken up here on this notify all call, but still hadn't had a chance. So you also have obviously C2, which was waiting and got woken up by this call. So after this call, you basically have P1 and C2 both competing to acquire the lock, right? So there are two outcomes. Either P1 acquires the lock first or C2 acquires the lock first. So in this scenario, the first scenario that I'm covering here, P1 won, right? So which is the worst scenario? Why? Because it's going to wait. It would have been better for the consumer to acquire the lock because then it would have consumed the data. So P1 acquires the lock first, checks the condition, buffer is full, it's going to wait, right? And then before C2 acquires the lock, P2 gets rescheduled by the scheduler and acquires the lock, buffer is still full, waits, and then eventually C2 is going to acquire the lock because P2, when it waits, is going to release the lock, so C2 acquires the lock, takes the data, consumes the data, and then calls notify all, which is going to wake up P1 and P2, which are waiting here, right? And then at this point, it doesn't matter which thread, which producer is going to acquire the lock first, because either P1 is going to acquire the lock, is going to write the data, or P2, it doesn't matter. So bottom line is, you can clearly see that it's not possible to have a deadlock here, right? Now, like I said, it's possible that on this notify all call, right, the thread that wins is C2, but that's an even better scenario, because if when P2 writes the data and calls notify all, C2, remember, after P2 calls notify all, both P1 and C2 will be competing for the lock, okay? Why? Like I said, because C1 called notify all, which woke up P1 and P2. So P1 at this point, right, it's waiting on the lock to be released, right? And obviously so is C2 that got woken up by this call here, right? So in the first example, P1 acquired the lock first. In this example, C2 acquires the lock first, right? But before it acquires the lock, like I said before, P2 gets scheduled, acquires the lock, waits on full because the buffer is full, releases the lock, and then, like I said here, C2 is going to win, and obviously is going to consume the data, and is going to notify all, which is P2 waiting here. and then as you can see, things work normally because now P2 gets scheduled. It's going to acquire the lock, and it's going to put the data, and then it's going to call notify all. There is nobody waiting, it doesn't matter. So you see that it's not possible to have a deadlock anymore. Okay, so I hope you found this explanation useful. Like I said, I built on the excellent answers from those two users on Stack Overflow, and created here using the sort of same graphic using notify all. So to summarize, if you have more than one producer thread or more than one consumer thread for this sort of problem, always use notify all. It's okay to use notify if you have only one producer and one consumer thread. I hope you found this video useful. I'm Nilton from craftofprogramming.com. Thanks for watching.